Alright, so we move the last subtopic, okay, for this chapter and also for this semester 2019-2022. Okay, so which is a mathematical induction. Mathematical induction ni dia tak susah, believe me, but you have to be creative. You have to be creative to relate. Okay, alright. So let's see what is the mathematical induction. This is the motivations for mathematical induction. Kita keyword dia adalah induce lah. Kita induce. Okay, suppose we have a ladder. And we want to know whether we can reach each steps on the ladder. Maksudnya apa? Kalau kita ada tangga ni, boleh tak kita naik ataupun kita panjat tangga ni sampai ke atas from the bottom to the top of the ladder? Boleh atau tak? Okay, so let's see what is the relationship between this mathematical induction with a ladder. Okay, so we know two things. From this ladder, we know two things, that we can reach the first rung of the ladder, and the second one is if we can reach a particular rung of the ladder, then we can reach the next ladder. Betul tak? Maksudnya apa? Kalau you boleh step on the first, on the bottom of the ladder, you boleh pijak dekat sini. Maksudnya you boleh pergi to the next level. Okay? Kalau you boleh pijak kat sini, sama ada you boleh pergi naik panjat lagi ataupun you tak mampu, hanya kat sini saja. Okay? Okay, that is the motivation. Okay? Alright, so let's see the mathematical induction. Okay, we have a few steps that you have to follow. Okay, hanya 4 step saja. So, apa kita punya objective for mathematical induction is we want to prove that the statement, Pn is true for each integer n greater than or equal to n0. So, what is a Pn? Pn ni adalah proposition lah actually, which is a statement lah, kan? Okay, is true for each integer n greater than or equal to n0. N0 ni adalah apa? Dia adalah initial value. Initial value. Okay, initial value. Okay, so let's see the step for mathematical induction. As I said earlier, we have 4 steps of mathematical induction. The first one is we want to prove that the statement is true for n is equal to n0. Okay, n is equal to n0. So like I said again, n0 is initial value. Okay, so what is the second step? Second step ni kita hanya assume that the statement is true for n is equal to k. Hanya assume. And then you have to rewrite the statement again. Alright, what is the third step? The third step, since we already assumed in the second step, in the previous step, so now in step 3, we want to prove that our assumption is true. Which is, the statement is true for n is equal to k plus 1. The previous step is we just assume that n is true, for n is equal to k. The statement is true for n is equal to k, but in step 3, we want to prove our assumption true, which is n is equal to k plus 1. So the fourth one is a conclusion. Therefore, the statement is true for each integer, and greater than or equal to n, which is the same as the objective. Okay, so how to memorize, how to remember? You ingat, kalau you boleh pergi ke next level of the ladder, kalau you boleh panjat ke tangga yang lain, so you can move to the next slide, to the next rung lah. Okay. Alright, so let's see the example. Believe me, Okay, mathematical induction is not difficult, but the important things is you have to understand the concept. You have to know the step. That's all. Okay, inshallah. Okay, so use mathematical induction to show that 1 plus 3 plus 5 plus until 2n minus 1 is equal to n square for any positive integer n. Okay, so tadi saya disebut n naught, n naught, n naught. Okay, n naught ni adalah okay, initial value. So, inilah adalah you punya n naught which is initial value. Okay, so let's do it. So, macam mana nak guna mathematical induction to show that okay, the series okay is true. Alright, so the first step yang pertama cakap apa? Step yang pertama cakap prove that the statement is true for n is equal to n naught. Macam mana nak tentukan dia true? Okay, nak tentukan dia true adalah bila you substitute the initial value. Okay, sebab dia kata prove that the statement is true for n is equal to n naught. So, the first step is actually kita nak provekan dia bila initial value masuk pada left hand side and right hand side of the statement, value dia adalah sama. So dia adalah true. Let's say kalau you masuk initial value dalam okay, left hand side of the statement, okay, you dapat 1, but for the right hand side of the statement you got 2. So left hand side dengan right hand side tak sama, so statement is not true. Dia true kalau you got the same value for both left hand sides as well as right hand side. Okay, so let's see. Okay, kena tulis ni. Let P N okay, 1 plus 3 salin je balik. Okay, this is the first step. Dia ada 3 dot plus 2n minus 1 kena letak dalam kurungan lah sebab 2n plus 1 ni okay, satu nilai okay, equal to n square. So what is the next step? The first step is we want to prove that okay, so sorry, 1 ni dekat sini. Okay, 1 ni dekat sini. The first step, 1 ni dekat sini, prove that the statement is true for n is equal to n naught. So n naught here is 1. Okay. So left hand side, okay, LHX okay, stand for left hand side. Okay, left hand side, okay, you masuk dekat n sajalah. Sebab apa? N is equal to n naught. N naught kita adalah 1, dapat daripada mana? Ni, dapat daripada sini. Okay, initial value. Kita masuk dalam n sajalah. N is equal to n naught. Okay. Alright, so kat sini sebab dia 1, 3, 5 tak perlulah kan. Okay. So we have 2n minus 1 kan. So sama dengan 2, n adalah 1. Okay, minus 1. So you got what? 2 minus 1, 1. So for right hand side, okay, you ada n square sahaja. So 1 square, you got 1. So sama tak kiri dan kanan? Sama kan? Okay, so sama tak kiri dan kanan? Sama. Okay. Okay, therefore, since left hand side equal to right hand side is equal to 1, then Pn is true. You mesti conclude. Conclusion ni ada. Okay, satu markah. Okay, so number 2, we assume that okay, Pn is true. Kita assume saja. Assume for okay, Pn is true for okay, n is equal to k. Ini nombor 2. So assume Pn kita apa? 1 plus 3 plus 5 plus until 2. Jangan lupa kurungan 2n plus 1 is equal to n square is true. Okay. Sebab dia adalah kat sini dia adalah reason adalah assume that Pn is true for n is equal to k kan, n is equal to k. So kat sini pun dia akan berubah. Okay, which is sini pun akan jadi k lah. Okay, sini pun akan jadi k here as well. Okay, faham? Sebab dia kata assume that Pn is true for n is equal to k. So we assume that k lah, here also pk. Sebab n sekarang adalah k. 2k minus 1 over equal to 2k square is true. Okay, so that is step number 2. Okay, let's go to step number 3. Step number 3 is we want to prove that K yang tadi lah, K ni adalah K kecil lah. Okay, Pk is true for n is equal to k plus 1. Pn sorry sangat. Okay, prove that Pn is true for n is equal to k plus 1. Okay, so we want to prove that Pk plus 1. So dia jadi apa? 1 plus 3 plus 5 plus 3 dot Okay, you have a 2n plus 1, right? So dia akan jadi 2n plus 1. 2n sekarang adalah k plus 1. Okay, 2n plus 1 equal to n square. So equal to k plus 1 square. Those yang macam pening. Okay, let me see. Okay, let me show to you. Ini adalah 2n plus 1. Ini adalah n square. Sebab apa? Sekarang n kita adalah k plus 1. So we replace every n with k plus 1. So apa nak buat? Now we update. Ni simplify lah kan. So dia akan jadi PK plus 1 akan jadi 1 plus 3 plus 5 plus okay 2K plus 1 plus 1. Soalan dia apa? Sorry, soalan dia adalah soalan adalah 2n minus. Sorry ya, kat sini minus 2n minus 1. Okay, 2n minus 1. Okay, so sini pun minus 1 lah. Okay. Alright, so sini akan jadi apa? Mesti dalam kurungan 2K plus 2 minus 1. So yang akan dapat sini adalah 2K plus 1 which is equal to K plus 1 square. Okay, so sekarang okay, apa yang kita nak buat? Kita nak buat adalah kita nak prove that this assumption, okay, number step 2 kita just assume je that lah true. Step 3, okay, kita prove that Pn is true for n is equal to K plus 1. Okay, kita dah buat ni, kita dah ganti n dengan K plus 1, right? N dengan K plus 1. So apa nak buat sekarang? Okay, kita nak prove. Macam mana nak prove? Okay, kita akan consider left hand side. Sebab apa? Sini adalah left hand side. This one after equal sign, dia akan jadi right hand side. So we consider left hand side lah sebab kita nak show, okay. So left hand side we have a 1 plus 3 plus 5 plus 2K plus 1. Right. Okay, sebelum 2K plus 1 adalah apa? Sebelum 2K plus 1 adalah apa? Betul tak saya kata sebelum 2K plus 1 dia adalah 2K dahulu, baru 2K plus 1. Betul tak? Sorry, dia mesti 2K minus 1 dulu, baru 2K plus 1. Dia mesti 2K minus 1 dahulu, baru 2K plus 1. Sebab apa? Contoh, kita ada 1, 3, 5 sampai, let's say, sampai 11 kan? Tapi sebelum 11 tu adalah 9. 11 adalah, ini contoh ya, 2K plus 1. Sebelum 11, 2K minus 1 lah. Betul tak? Okay, kalau K ni adalah untuk jadikan 2K plus 1, 11. So what is K? 2K is equal to 10. K is equal to 5, right? Okay, so 2 times 5, 10 minus 1, 9. Okay, faham tak sequence dia? Okay, sebelum 2K plus 1, dia adalah 2K minus 1. Sebagai contoh yang ni. Sama kalau sini 1 plus 3 plus 5 plus, let's say sini 15. Sebelum 15 adalah 2K plus 1. Sebelum 15 adalah 2K minus 1. Betul tak kalau saya kata 2K plus 1 is equal to 15. 2K is equal to 14. Okay, K adalah 7. Okay, K 7, 2K 14 plus 1, 5. 2K 14 minus 1, 13. Betul? Okay, can you see? So kat sini lah. Kena tambah. Okay, you perasan tak? Okay, do you realize that actually 1 plus 3 plus 5 until plus 2k plus 1 ni adalah step number 2. 1 plus 3 plus 5 plus until 2k minus 1 equal to k square is our assumption in step 2. Now we have 1 plus 3 plus plus 5 plus until 2k minus 1. So maksudnya apa? Ni sama dengan k square. Maksudnya apa? This one actually sama dengan k square. Okay? So we update. Kita ada apa sekarang? We update now. We have this one actually adalah k square. You got from second step. K square tambah apa? Tambah 2k plus 1. This one you boleh simplify tak? Boleh. Boleh simplify, dia akan jadi k plus 1 square. Tak percaya, expand balik. K square, k square. K times 1, k times 2, 2k, 1 square, 1. Okay, apa yang you perasan? K plus 1 square is actually equal to right hand side, this one, S. Okay, so maksudnya betul kan? Kiri, you buktikan left hand side sama dengan right hand side, so proven. Okay, tulis perkataan ni, proven. Kalau soalan dia adalah show, so soalan dia adalah show kan? Show that. So you kena letak kat sini shown lah. Okay, so kat sini adalah shown. So kat sini adalah shown. Okay, so we are done on third step. So now we move to the fourth step, which is apa? Conclusion. Tengok sini. Okay, conclusion. Step number 4. Okay, conclusion. Okay, what is the conclusion? Conclusionnya adalah, okay, therefore, ini you better hafal. Okay, hafal je. Yang berlainan adalah depends on the question. Therefore, the statement okay is true for each integer n greater than or equal to n naught. Okay, that is the answer. That is how you use mathematical induction. Okay, so this is the exercise. You may try. Okay, tengok video berulang kali for your understanding. Okay, if you have any question, please do not hesitate to see your lecturer. Ask your lecturer so that you will well explain. Okay, so I think that's all for me. And this is the last video for this semester. Okay, so hopefully, okay, I wish you all good luck for your final exam. Okay, please do revision. Okay, nobody can help you, only you yourself can help you. Okay, jangan lupa buat revision. Tak faham, boleh refer your lecturer. Okay, so okay, see you again. Assalamualaikum, take care. Bye-bye.